Hi everyone. So today what we're doing is enthalpy of neutralization. Our syllabus outcome is conduct a practical investigation to measure the enthalpy of neutralization. So just a bit of revision, enthalpy is the change in chemical potential energy during a reaction. Molar enthalpy is enthalpy change per mole of reactant. Now the equation we use is Q equals mc delta T. Remember, Q is change in heat, and it equals the mass of the stuff that we're heating up times the specific heat capacity times the change in temperature. We also know that enthalpy is equal to our negative Q, so it's equal to the change in the amount of change of energy in our solution. So the change in kinetic energy is equal to all the energy that has come out of the molecules as enthalpy. So it's our changing chemical potential going into kinetic. And our molar enthalpy is just our enthalpy divided by the number of moles of reactant. So it's not the number of moles of stuff that we're heating up, it's the number of moles of things that reacted to release the heat. Now, enthalpy of neutralization, it's the thermal energy change in the reaction when an acid and base react in stoichiometric proportions to make a salt and 1 mole of water. And it's represented by the symbol delta H neut, so neutralization, or just delta HN sometimes. The value for the enthalpy of neutralization will always be a multiple of negative 55.9 kilojoules per mole. This is due to the neutralization reaction only forming a single covalent bond between the H plus and the OH minus. Each mole of water formed during the reaction will cause negative 55.9 kilojoules per mole of enthalpy change. So, enthalpy of neutralization. Let's have a look at this one. HCl plus NaOH gives us sodium chloride and water. So H plus Cl minus plus Na plus OH minus gives us Na plus Cl minus plus H2O. So what we've gone and done is we've created that bond between H plus and OH minus to create H2O. Okay, and that's what releases that 55.9 kilojoules per mole. Yeah, so our enthalpy of neutralization is calculated much the same way as other enthalpy changes. So the reaction of a known amount of reagent is conducted, and the change in temperature is measured. The heat of reaction is then calculated using Q equals mc delta T. So remember, our Q is the amount of energy that the stuff that we're heating up gains. Enthalpy is calculated through delta H equals negative Q. And molar enthalpy is calculated by delta H naught equals delta H over N. So what we're going to do is we're going to do this as a prac. So effectively what we're going to do is we're going to make a solution of sodium hydroxide. We're going to make a solution of hydrochloric acid. We're going to add them together and calculate delta H naught for that reaction. Now, because it's hydrochloric acid and sodium hydroxide, we're expecting 1 water molecule to form. So it should hopefully be about that negative 55.9 kilojoules per mole. Okay. So we'll do that, and that's it for today. Thank you.